This time, I will try to thoroughly understand AI in about 10 minutes. Even if it's your first time and you don't understand AI at all, I would like to aim to help you understand what it is, from the basics of AI to deep learning, which is especially used today. Now let's move on to the table of contents. Here is the table of contents. At first, as the foundation of AI, we will understand the definition, history, and AI so far. Next, we will understand the meaning and relationship of machine learning and deep learning that you should know. We will also understand the types of AI learning, and then learn about specific methods of machine learning. We will understand deep learning from the most basic simple linear regression. Move on. First, I would like to think a little about what AI is. As a definition, I think that what is generally heard is that a part of human intellectual behavior is artificially reproduced using software. However, this is a little vague. If a machine makes a decision even once, can it be called AI? The question arises. A rice cooker that cooks rice at 5 o'clock judges that it is 5 o'clock and automatically cooks rice. However, I do not think that such a timer function is called an AI rice cooker. Then, I also think that there is no clear standard on how much judgment it takes to say that it is an AI-equipped home appliance. In this way, AI is a fairly wide range of technologies and is ambiguous, so I think it is necessary to carefully determine what functions the software and machines that are advertised as AI have. Move on. AI has experienced many booms in the past, and is now said to be in its third boom. In the first phase, a system based on logic was developed, but it was terminated due to limitations in computer performance and other factors. Next, in the second boom, there was an AI called an expert system, and experts built rules based on knowledge, but these rules also had limitations and were discontinued. Currently in the third boom, the practical application of machine learning of big data is progressing, and in 2012, the team of Professor Geoffrey Hinton of the University of Toronto, Canada won the image contest by demonstrating overwhelming accuracy using deep learning. It seems that it spread all at once. Move on. I understand the image of old AI. I think the image of the second boom expert system is like this. A human expert formulates knowledge into rules and makes judgments. In other words, the more detailed the rules are set, the higher the accuracy, but it means that all rules must be constructed by humans. For example, if you use an expert system for what a doctor diagnoses, I think it will be an image of determining rules such as determining that if there is a fever and a cough, it is a cold. Move on. This time, I will understand the words and relationships that you should know. First is machine learning. Machine learning means that the machine itself learns data and formulates rules and patterns. It will be one of the technologies to realize AI. Next will be deep learning. This is automatic extraction of data features using neural networks. This is also one of the techniques in machine learning. Currently, I think that the mainstream of AI is deep learning within this machine learning, so I would like to deepen my understanding of these. Move on. We will understand the types of AI learning. There are 3 types of AI learning: supervised, unsupervised, and reinforcement learning. Supervised is a method of learning by giving a set of questions and answers to a machine. Unsupervised is a method in which only the problem is given to the machine and the machine learns the features by itself. Next, in reinforcement learning, the machine tries and rewards itself and learns to obtain the maximum reward. This time, the content to be understood will be supervised in this classification, but we will learn deep learning by firmly holding down the basic content. Move on. Let's understand what exactly machine learning is. First of all, we will learn what is called the most basic simple linear regression. The data have a linear function relationship. I don't think you're familiar with the word regression, but I think it's okay to think of it in the sense of prediction. Since there is data that can be represented by a straight line as shown in the upper left figure, we will find the relational expression. The purpose of finding the relational expression is to predict the y value from the x value, even for values that are not plotted. Given data, it derives a relational expression, and I think it will be a predictable AI. Considering the rightmost plot, the error from the line of the desired linear function is the actual value of y1 minus the value of the linear function, x1 plus the value of b. Increase. The same thing can be said for all plots, so if you add them all, you can find the total error. However, since it depends on the plot whether the error occurs on the top or bottom, the squares are summed. The parameters a and b that minimize the sum of these errors are the formula that expresses the relationship of this data. This is called the least squares method. In this way, finding a relational expression that minimizes the sum of errors is the same way of thinking in deep learning. Move on. There are many ways to do machine learning, but let's learn about another example. It's called a support vector machine. This time we will understand the simplest of the linear 2 class ones. First, a vector is a point, and a support vector is the point closest to the boundary. As shown in the figure above, find A and B so that the 2 points closest to the boundary of both classifications, that is, the support vectors, have the maximum distance and margin from the boundary. In a nutshell, a support vector machine finds a relational expression so that the closest point is the maximum margin. In general, as shown in the figure below, the data is not neatly classified into 2, and the data is intricately intertwined, so a penalty is given to obtain the relational expression. In other words, find A and B so that the penalty is minimized and the margin is maximized to derive the relational expression. Move on. Next, we will understand perceptrons and artificial neurons. This will model the movement of brain cells, as shown in the diagram above. Specifically, as shown in the figure below, artificial neurons have inputs and outputs, just like nerves. Each input is weighted and computed in a neuron. If the sum of these values is greater than the threshold, it will output 1, and if it is less then it will output 0. As shown in the example below, if each input is 1, 2, 3, all weights are 1, and the threshold is 5, the formula is satisfied, so 1 is output. Increase. In the explanation just now, the output is either 0 or 1, and the step function is used. Each neuron will output based on a predefined function. For reference, the functions that are often used are introduced on the right side. First, just understand that various functions are used for output. Move on. Understand neural networks. This will be used by connecting the artificial neurons mentioned earlier like a network. The simplest neural network consists of an input layer, an intermediate layer, and an output layer, as shown in this diagram. This time, the figure shows an example of judging the images of Maru and Cross. We will learn about specific movements. The input layer has the role of simply passing the 3x3 resolution signal to the intermediate layer as it is. However, in the middle layer, the input values are weighted. This weight determines which feature is captured by the neuron. For example, if the Y1 neuron captures features where the top left and middle are black, the weights of X1 and 5 are increased. The higher this weight, the higher the output when matching the image. The output of the hidden layer is passed to the neurons of the output layer. The output layer is similarly weighted. In the output layer, there are 2 neurons for judging Maru and Cross. In this figure, the image of X is input, so the weight of the output of the neuron that matches the feature of X in the intermediate layer is increased. So the weight from Y1 to Z2 increases. In this way, when the X pattern is input, the weight of the intermediate layer that matches the feature increases, and the weight for the neuron determination of the output layer also increases, so X is determined. Increase. The expressions output to these neurons are shown on the right. Next, let's take a closer look at this topic. It shows an example in which the variables described in the previous figure are replaced with specific numerical values. An example is shown at the top, but the data to be given will be the learning data and the correct answer data. The data to be optimized will be the numerical value in white. Specifically, the weighting and threshold of each neuron in the intermediate layer and output layer are optimized. Since many patterns are given to the learning data and the correct answer data, the parameters are optimized so that all patterns are close to the correct answer. In other words, AI learns by optimizing this weighting and threshold. As shown in this figure, features are captured where the weight in the intermediate layer is high, and the weight of the feature that matches the judgment of Maru or Cross is high in the output layer. By learning in this way, it becomes possible to recognize images. Move on. Finally, we will understand deep learning. We will understand the most basic convolutional neural network in deep learning. The basic idea is the same as the neural network we understood earlier. First, regarding deep learning, a neural network with 2 or more intermediate layers as shown in this figure is called deep learning. 2 of the convolutional layers and the max pooling layer are intermediate layers. A convolutional neural network is a method of learning by subdividing intermediate layers in a convolutional layer. This figure is an example, so in actual use, the model and numerical values will be changed according to the performance. Let's take a look at this diagram. In the case of an 8x8 image, it is subdivided into 3x3 sizes in the intermediate layer and input to the next neuron. Also, after shifting by 1 pixel, the next 3x3 image is input to the next neuron, and the image information is received by 6x6, 36 neurons. Also, in order to recognize more complicated features, 32 groups are composed of these 36 neurons as one group. In this figure, we can see that there are 32 groups of 36 neurons in convolutional layer 1, so there are 1152 neurons. Image recognition is performed using a large number of neurons. The next convolutional layer 2 is similar. 6 times 6 is subdivided into 3 times 3 and input, and the feature is recognized. As for the next max pooling layer, we will grasp the features with rougher precision, such as making the 4 times 4 image into the size of 2 times 2, and achieve recognition that is resistant to misalignment. As shown in this figure, we input only the maximum value into the neuron in the 4-part box. By identifying only the maximum value within each delimited frame with the next neuron, it is possible to capture rough features. Finally, it is input to the output layer, and the image is judged by calculating including the threshold value. In the case of image recognition like this time, when judging 10 numbers from 0 to 9, the output layer also judges each number with 10 neurons. As you understood earlier, AI acquires the ability to recognize images by having AI learn answers to input images and optimizing weights and thresholds in all neurons. So far, we have understood deep learning. There are many technologies about AI, and there are many other contents, but this time, I have understood with the goal of creating an image of what AI is like. In recent years, more advanced AI has been developed and has made remarkable progress, so I think that this channel will also be a topic that I would like to deal with as needed if it is popular. This is the end for this time.
We will continue to take on the challenge of making things using IT like this, so please give us a high rating and subscribe to the channel. See you next time.